Okay, welcome to the first video in our course, Math 2260, Probability and Statistics. So in this first video in Lecture 1 here, I'm going to give you a very quick overview of what probability and statistics are, and then we'll dive right into the first topic here. So as the title suggests, this is probability and statistics. So probability is a branch of math that deals with what are called chance or random processes. So it's a branch of math dealing with chance behavior. Now, sometimes chance is synonymous with random, but we'll try to be a bit more clear about that as we go. Now, statistics is a branch of science that deals with data analysis. So analyzing data, collecting data, graphing data, making predictions about data, and the two of them go hand in hand. So often those predictions that statistics needs to make requires the math that comes from probability. So we are going to spend about 2/3 of the course, the first 2/3 of the course, talking about probability, and then we'll spend the next or the final third of the course talking about statistics. So I'm going to dive right in. We're going to talk about probability. And in your textbook, this is going to correspond to chapters, little bits of chapters 1.1 all the way up to 1.3. So I'm mixing and matching a little bit here, but this is going to do with basic definitions. And really what's going to come up is that we are going to be talking about sets. So a set is basically a mathematical term for a collection of objects. And the set theory that we are going to be introducing is pretty basic, but it's really going to set the stage for all of the math that follows in terms of probability. So this first lecture today is really going to be about understanding the basic terminology of sets. So I'm going to type out all of these definitions and post them on the Blackboard page along with the link to this video. So you don't really need to worry too much about getting the formal definitions down. We will get there. Okay? So when we deal with probability, the first and most important thing is that we are always going to be finding ourselves in a situation where we have what's called a probability experiment. Now, a probability experiment could really be a lot of things, but it's any situation, let's say any model that produces data. And not just data that produces random data. Now, random doesn't necessarily mean any value you want or any type of thing you want, but it really depends on the situation we're talking about. So the very basic things that we're going to be starting with are these. Flipping a coin. Flipping a coin is an example of a probability experiment. Rolling a six-sided die. That's an example of a probability experiment. The basic ones we're going to use at the beginning of the course: draw a card from a standard deck of cards. And all of those things count as probability experiments because they produce data. And in some way, it's random. You don't know what's going to happen next. Now, just because you don't know what's going to happen next doesn't mean that we can't figure out all the types of things that are going to happen. And so this leads us to the next definition. It's a pretty important one. This is something called a sample space. Now, a sample space is a set. It's a collection of outcomes. So this is going to be the set of all possible outcomes in our experiment. So that could be very simple or it could be very complicated. It really just depends on what your experiment is. So if you flip a coin, we're always going to use this fancy letter S to stand for the sample space. It's a simple symbol that's going to stand for the sample space. The sample space is a set. So in mathematical terms, we use these curly brackets to start and end the set. And then we put into the set all of the possible outcomes from that experiment. So when you flip a coin, there are only two possibilities, heads or tails, or whatever you want to call them. But that's it. It's a simple probability experiment. It's random. You don't know what's going to happen next, but it's very limited. When you roll a die, a six-sided die we're going to assume, then the sample space is a little bit more complicated, but also pretty simple to understand. When you roll the die, it's going to land with some face up, and that face is going to have a bunch of dots, 1, 2, 3, etc., all the way down to 6. So that is an example of this sample space. Now, we are going to be using sample spaces a lot, and in the beginning, when we start modeling probability experiments, this is a really important one. Okay, so the next thing that we're going to talk about is an event. Now, an event is just some subset of the sample space. Now, that's starting to get a little bit abstract, so I'm going to try to show you what I mean by that. And I think a good way is to put it in the context of an example. So a basketball player shoots 3 free throws. So when you shoot a free throw, you take the shot, you either hit it or you miss it. And so to try to show you a way of coming up with the sample space, I'm going to introduce this tool called a tree diagram. And now we're going to be seeing tree diagrams a lot in the next couple of weeks, but basically it works like this. In the first situation, in shot number 1, there are 2 outcomes. You either make the shot or you don't. Now, the second shot has similar outcomes, hit or miss, and then the third shot also works the same way. Hit, miss, hit, miss, hit and miss, hit and miss. Now, where the tree diagram is useful is that you follow each branch of the tree to get to the outcomes. So one of the possibilities is that you make all three free throws in a row. Hit, hit, hit. The next possibility is hit, hit, or miss. And as you walk through all of the branches, you start collecting all of the outcomes. Now, the top half is made up of 4 outcomes. Hit is always the first one, but as soon as we go to the bottom half, we now start seeing the outcomes where miss is the first. And in this way, we can easily come up with all of the different outcomes from this experiment. Now, the sample space for this particular experiment is made up of all the possible outcomes. So the experiment here is to shoot 3 free throws, and you're interested in recording the order in which you make them. So if we're interested in the order of making the free throws, then we can just take a look at our tree diagram and write everything out. So it's pretty straightforward to keep track of all of these outcomes. And by the end of it, you should be able to see pretty clearly that we have 8 outcomes. So this is what we call the totality of everything that can happen in this experiment. 8 possibilities. You have a basketball player taking 3 free throw shots. They have all of these options. Now, what we want to do is talk about some different events. And so let's talk about event A. We'll call it event A. This is the event where no free throws are made. And so we're going to come up with event A. We're going to give it a symbol, a name. We'll call it A, and it's a subset. So it also gets curly brackets because it's like a child set of the parent set. And what we want to do is put all of the outcomes where no free throws are made. So if I take a look at the sample space, there's only one outcome where no free throws are made. And that's this one in green that I've written down. And so I will list this in. And this makes up event A. Now, event A, this is called a simple event because there is only one outcome there. But I don't have to have simple events. So for instance, let's say event B. Event B is where we have one free throw made. Now, if I take a look at the sample space or the tree diagram, whichever you'd like, what our job is going to be now is to look at all of the outcomes where only one free throw is made. So we've got one there, we've got another one there, and another one there. And because the order matters, we are going to be very careful in how we write this out. And so apologies for all the menus here, but essentially event B is now made up of 3 events. You could either make the first one and miss the next 2, make the middle one, or make the last one and miss the others. So this is what event B is. It is a subset of the parent set there, of the sample space. This is what we call a compound event because there is more than one outcome.